Hello everyone, Mr. John here from Areteem Institute, excited for the return of Thursday Tidbit for 2022. We are doing something different this year. Check out our previous video explaining the updates for this year, and today we're going to be introducing the mathematics behind Elo ratings for chess. Little bit of inspiration at the beginning. Last December, Magnus Carlsen defeated Jan Nepomniachtchi, or Nepo, over a span of 11 games to remain the chess world championship. Going into that game, their respective ratings were Carlsen had a rating of 2856, while Nepo had a rating of 2782. Now, these numbers don't mean much to us unless you know what they mean. Obviously, higher is probably better, especially since we know Magnus won the match. But what do these ratings mean? Now, these ratings are FIDE ratings, which is a type of Elo rating. So every organization in chess might have their own ratings. This Elo rating system is used in other places too, but this one was first designed by Arpad Elo. It was used in the United States Chess Federation first. FIDE has their own version. They're all relatively similar, but there's just some differences in the details that we'll maybe see a little bit today, but maybe we'll discuss that more next week as well. So, what do we want in a general rating system? Why would we want these numbers? What purposes would they maybe serve? Well, there's two main things I want to point out as being important for these things. First one is that they are predictive of future performance. We would like if Carlsen has a higher number, a higher rating than Nepo, we would want that to mean that if they played, Carlsen probably could beat Nepo. We want to have numbers where we have a good sense, right? If we're a spectator or if we're someone following the sport or competition, we can know, okay, who's likely to win, what is going to happen there. And further, we want it to be actually predictive numerically. So we wanted to have some rule or say something of how likely is it for one person to win over the other. Other purpose is we probably want it to mean something and it came from somewhere. So we probably want those ratings to be based on a previous performance. These things don't necessarily have to be true, right? If you have a power rankings in a newspaper, right, they might make their own predictions, not only based on previous performance, but who they think is improving and who's going to match up well against each other, things like that there. But as far as a rating system, we want to feel like someone has earned the rating. They have their rating because they've won in the past. They've beaten people in the past that way as well. And we'll see today how this Elo system and the ranking system serves these two goals and two purposes, and how we can use the system to update itself and come up with rating systems on a fly. So, quick explanation of scoring in chess. In chess, points are typically given as follows. When two people play a game, 1 point is up for grabs there. Right? This is maybe a little different than a normal competition you're thinking of because we have a draw. So we have three scenarios that can happen here. Right? If A wins, A receives 1 point and the other person receives 0 points there. So if A wins, A receives the 1 point in that case. Right? Then if they draw, so this is a possibility in chess, and so that is a very, actually pretty likely possibility, but if they draw, they both receive 0.5 points. I want to do this from the perspective of A a little bit here. So if we're A, right, if we win, we get 1 point. If we draw, we get a half a point. And if B wins, A receives 0 points there. So this scoring system isn't too difficult to come up with and makes a lot of sense there. Now, why do we need this scoring system? Why can't we just do win, lose, draw? Well, we want to make sense of this in terms of the predictive nature of these Elo rankings. And so the prediction here is based on that point system. So a 1 means win, 0 means loss, 0.5 would be draw, but of course our prediction system can be anywhere in between that as well. Now this formula is a little bit complicated here. So if we have two players, so player A has a rating RA, player B has a rating RB, they play each other, the system predicts that player A will get 1 divided by 1 plus 10 raised to the RB minus RA over 400. And player B, we're going to focus mostly on A here. Player B will get the opposite amount of points. So a good thing to check algebraically, check that these do add up to 1. This system is giving out 1 point per game, and we can make everything work that way. Now, this exponent seems a little bit weird, but remember we have a fraction, so we have a reciprocal. So we have 1 divided by this there. A good example to look at first would be, what if they have the exact same rating? Right? If they have the exact same rating, we have this is 0. So then we have 1 divided by 1 plus 10 to the 0th power, right? So this whole thing is 0, meaning we have 1 over 1 plus 1. We have a half for A and a half for B. So that makes intuitive sense there. Now, what's a little bit weird in this case is you might think we have a typo here, the ratings are backwards, but this is okay, because for player A, remember that if for player A, if this is negative, we have a smaller number, right? And so we have 10 raised to a small power, meaning that this portion is going to 0. So the good way to think about this is that if RA is bigger than RB, so if RA is bigger than RB in this case, then we have 10 raised to a negative power there, meaning we have a small exponent, or we have a negative exponent, so we have a small number. So this term is small. And why is it important for that term to be small? Well, then we basically have 1 divided by something a little bit bigger than 1. So that's going to be a little bit less than 1, right? If this rating is much, much bigger, that term is basically 0, and so player A will get all of the points. And you can see on the other side, then player B will get the opposite, or 1 minus that amount of points in that case. But it's a lot of times easier to understand these looking at a numerical example. So if players A and B have ratings of 2,500 and 2,000 respectively, the Elo system predicts that player A will get roughly 0.95 points. So here's what I mean by the negative exponent. Right here we have 1 plus 1 plus 10 raised to the negative 5/4, and so that's pretty small number. A will get almost all of the points, and B will get roughly 0.05 points there. So most of the points will be given to A in this case. Now, you might ask the question here, and this is a natural question. Well, I thought we could only get 1, 0, or 0.5. And so that's true. So 0.95 means close to a win, right? Maybe a draw is somewhat likely, a loss is unlikely, but these things do work better, and I'll say a little bit more about this in a second. This is usually better the more data you have. This isn't a rating system that you want to be updating all of the time. And in chess especially, a lot of the times people will play multiple games in the same time period. So the better way to think about this, and this is like our Carlsen Nepo example, well, what happens if they play 10 times? So A has that rating of 2,500, B has the rating of 2000, they play 10 times, well then the Elo system predicts that A will have 9.5 points, so that is, right, the 0.95 points per game times 10, and player B will get 0.5 points there. And so this is the better way to think about this in that case. So we use the system to get their points, but turn that into like what happens if they play 10 times. So if they play 10 times, this system is saying, okay, you could interpret this as A will win 9 times and there will be 1 draw. And that will give you the 9.5 and 0.5 points there. Of course, it doesn't need to work out explicitly that perfectly, but it is okay in terms of thinking about the outcomes, and it's easier to think about the outcomes when you have multiple games there. Now, we said we also wanted this system to be based on previous performance. So how do we use what we've done so far to update the information? How do we give people a new rating after they play some games? So after they play some games, the person gets a new rating R based on their predicted performance. So in this previous slide, we said if the A and B play there, we would predict A to get 9.5 points. We're going to focus on A here in this case. So it's based on their current rating, the predicted performance, and the actual performance. So the actual performance is based on the actual games that were played in this scenario. So what is the new formula? Well, you take your old rating, and it's actually pretty simple from here, right? You look at the difference in how you performed versus the predicted performance, and we multiply this by some constant k in this case. K is a constant for these things there. We are going to talk about that a little bit more in the next video, so stay tuned next week, but think about what different values of K might do. And for our situation, for the FIDE rankings, K equals 10 is used for high-level chess there. So let's think about our example then with this information there. So what did we have in our example? And this gives you an idea of how the rankings and ratings are updated. So we predicted that this player with a rating 2500 would get 9.5 points in 10 games. Now, let's suppose they win 8 times, draw once, and lose once. So this is giving them a total of 8.5 points. So they did not perform up to expectations. They did worse than we would expect here. So their ranking will go down. How much will their ranking go down? And how much will this rating Elo affected by this performance? So let's look at the formula. Remember, our formula here is given by the new rating is based on the old rating, the K value, and their actual versus predicted performance. So just on the side here, let's remind ourselves what all of our information was. So the old rating was 2500. We are assuming we are doing the K equals 10 case here. Their actual performance was they got 8.5 points, 8 wins and a draw, and their predicted performance was 9.5 wins. Of course, we're doing the approximation version here anyway. In practice, these would be done with more specific numbers. But now we can use all of this to calculate the new rating. So we have the old rating, 2500, plus 10 times, and now we're looking at the difference between their actual performance to the predicted performance there. So it's pretty easy to see, and the numbers actually work out nicely in this case. We are actually just subtracting 10 from this, and so the new rating will be 2490 in this case. So if you want to go back and look at the numbers for the player B, or the rating 2000 player, you can see what happens there. And compare those things as well. That's another thing we might discuss in the next video too. Now, for next time, I have some questions for you to think about. We will answer this in next week's Thursday Tidbit. So first of all, put some of these formulas to practice with the Magnus and Nepo games. So they played 11 games based on their ratings. How many points would you predict for Magnus? How many points would you predict for Nepo? Now, compare this to how they actually did, right? You can look that up. These games were played. Spoilers, Carlsen won, but you can see the actual results there. And see if you can understand the math and do the math for how this should affect their Elo rating. And you can check some of that information online too. But that will be it for this video. Stay tuned for answers to those questions and a little bit more discussion next week. If you have more ideas for Thursday tidbits or challenges, right? You want me to talk about the math in your favorite video game, movie, novel, story, things like that. Share ideas for math Thursday tidbits in the comments below. If you like this video, please subscribe to our channel for updates, and I hope to hear from everybody and see everybody soon. Goodbye.